Now, AI models are static. They get trained and then you have the static model. That's why you can download them, for example, when you want to use local LLMs. Now, because they're static, every time you activate it, every time you wake it up, it knows nothing about who you are, about what you're trying to do, about what the current task is at hand. That's why the more context you give it, the better answers you're going to get. So that's why nowadays we have things like skills.md file or agents.md file or soul.md. These are all files that get read in at the beginning of some kind of interaction with a model to kind of give it some context. Now, another way you can give a model context is using retrieval augmented generation. And that's what this video is about. So if you want to find out more, please let me explain. So what is RAG? Well, basically, data is retrieved from an external source. That could just be the internet, or it could be your own set of documents or your own databases. And that gives the AI model some context about what you're trying to do. Could be source code, could be a GitHub repository. Doesn't matter what it is. Okay, and then you basically give it a prompt and say, this data here, database, internet search page, internet results, source code, I want you to do the following thing. And that's when you augment your prompt. And then the generation part from RAG means you then send that over to the model and it generates a response. So what I'm going to do today is we're going to use Python to fetch web pages about a particular company. You pick the company, its financial news. Then the augmentation part is you take all that data and you say, tell me about the financial situation of this company based on this data. Or you could do other things. You could even say, should I buy or sell? Of course, it could be risky, and I'm not suggesting you take that as financial advice, but you can ask it, what's going on with the financials of this company. And then the model takes the data you've given it plus the question you've given it and then generates a response for you. So in this particular case, I'm going to use the Google Finance website, and there you can ask for different companies based on their stock number, the stock name. So I'm going for Apple only for the fact that there's always something in the news about Apple. So we're going to get good results with this. Now, Apple from the NASDAQ. And then it reads that page, and that page has links to other pages carrying stories from other news outlets. So we're going to parse that initial page, see what all the other links are, and then go and fetch those pages. So now we might have 10, 12 stories, current stories about the situation of, in this case, Apple, but any company that you want to go and get it. And then you save all that information into a file, in this case using the stock name, so AAPL, Apple News.md, which is going to be basically, this is the data, the context that we're going to give to the LLM. It'd be pointless asking a local model, tell me about the financial situation of Apple. It doesn't know anything about it. Its cut-off date in its training was, a long time ago. It's too small to keep that kind of information. So we're giving it that information. So here's the first Python script. It's called scrapegooglefinance.py for Python. It uses Beautiful Soup, which is a library, to parse HTML and extract the news story links. It fetches pages using the URL lib, which is a Python library. It cleans it all up using some functions that have been written in there. It then goes and scrapes each of these articles, extracting metadata and likely paragraph text, because obviously today's web pages are quite complicated. Sidebars, navigation bars, there's JavaScript, there's all kinds of different things, footers and headers, and loads of stuff that goes in. We try and work out what we want to grab from it, and then finally that's all written into a markdown file. Now you can find this script in my GitHub repository, but actually you can vibe code your own one to do it exactly however you want to do it pretty easily, because we're only talking about 100, 200, 300 lines of Python, and all of the major AI models can handle that for you. So do it however you want. So that's the retrieval phase. Now, the next thing to do is you read that news file that's in that markdown file. And then what you do is you add to it a prompt like, what's the financial situation of this company? And then you submit it to the AI. In this case, I'm using Ollama, and I'm going to use Gemma 4 E4B, effective 4 billion. So that's all for free. You get a free model. You can use Ollama locally on your PC, and you can send in all that information that you've collected using the Python script and say, right, now give me some analysis of all this data I've given you. And finally, when you get a reply from the AI, it will print it out, and that's all inside of a file called askai.py. So it reads the markdown file, it builds a prompt. Okay, then it sends it over to Ollama because it's, again, a request. So you send the request over to the Ollama API, and then it uses JSON to specify what model you want to use and all that kind of stuff. And the actual script is also allowing you to override the default question of, tell me the financial situation, what model you're going to use, and so on. So you can override all of that with that script, and then you can ask it any questions on all those news stories that you collected about that particular company. Again, you can find this script in my GitHub repository. Again, it's very easy to vibe code this. It's not very many lines of code. And if you wanted to, you could make this talk to ChatGPT, you can make it talk to Claude, you can make it talk to LM Studio, you can do whatever you want with it. So I've just got Ollama in there using the Gemma 4 model. You can, put this in whatever model you want it to. Okay, let me show you this running. Okay, so here is the Python script. So we're going to run that now. Okay, so it says it wrote 12 articles to this markdown file. Let's have a look at that. Okay, so there's the markdown file with all the data in it. And now we have a second script, which is called Ask AI. Okay, and that uses the markdown file and then sends a request over to Ollama. So let's try that. Okay, so that's talked to the LLM running on my PC, and it's come here now and it's given me a full analysis of all those different articles I sent it. So you give it a lot of data in, it's got a lot of stuff to work with to come back with the answer. Okay, so I've got the pipeline working now. I scrape the web pages, I bring it all together in a markdown document, I add in the prompt that I want to ask the LLM, I send it to the LLM, and it generates a response, retrieval augmented generation. However, there is a problem, and this is a problem that everybody who's ever tried to scrape a web page will meet, and that is that not all pages can be easily scraped with Python and with Beautiful Soup. Some of them come back just with no text at all, and that can be for a variety of reasons. Maybe they are JavaScript heavy, maybe it's getting denied, maybe it's got a cookie wall, a captcha. So this is from the markdown file. You can see that this particular web page, it just failed to get the text. So I've lost a valuable source, valuable set of data in the RAG process. So to get around that, I'm going to use Decodo's Web Scraping API, and they're also the sponsors of this video. So instead of trying to fight an anti-bot system or maintaining my own scraping infrastructure, I just asked Decodo, go and scrape that web page for me, and it comes back with a structured result. It handles all the JavaScript heavy pages, it handles retries, it handles captchas, it can get around cookie walls, it can do everything for me. While I concentrate on the pipeline, on the workflow I want to create, Decodo does all the heavy lifting for me, which means I don't need to maintain my own scraping infrastructure. Talking of a scraping infrastructure, Decodo's infrastructure includes 195 locations worldwide with over 125 million IP addresses. So rather than using Beautiful Soup, I just instead say to Decodo, go and get that page, and it comes back with everything that I need. Again, you can see the Decodo version of the script in my GitHub repository. It really is easy to use. They give you examples for Python, JavaScript, and so on. Look, just a few lines of code there. You just specify what you want, and you go and ask it, and it will give you back the result. And the nice thing is you can follow along for free because they do have a free scraping API plan with up to 2,000 requests, and you don't even need a credit card. If you need more than what's in the free tier, then you can use my discount code Gary Explains to get 10% off. Okay, so here is the Decodo version. So it doesn't use our own scraping, it uses Decodo to scrape it. So let's run that. Okay, so that's created the markdown file. Now, if we search for any errors in that, saying it couldn't fetch pages, there are none. So we've had a perfect result that have all come back. And now we could pass that into the Ask AI script. So you have it, a simple AI workflow pipeline. You fetch the data, you add in a prompt, and then you ask the LLM to give you back a result. And if getting data from the internet is difficult, scraping web page difficult, then there are services like Decodo's Web Scraping API that can do all the heavy lifting for you. Okay, that's it. My name's Gary Sims. I'll see you in the next one.